Okay, let's start. Mm, Today we'll talk about first thing is props. So, what are these props? These are like health checks for your pods. Health checks, like let's say I'm running a pod, some pod, and I want to know if the pod is not working. I want to know if the pod is okay. I want to know the status, right? And based on the status, I want to take some action. Maybe restart the pod, delete the pod, recreate again, some actions. So at the time, sorry, these probes will be helpful. So these probes, so we have multiple kinds of health checks actually. We call them probes in Kubernetes. So each and every probe, I mean each and every health check have its own use case and when and what it will do, when it will do. So that's the thing. So I mean, we don't do anything for probes manually, but of course we have to configure the probes saying that, hey, I want to configure this health check for the pod. I mean, whatever the application container inside it, all these things, and those probes will take care of us. I mean, the health of the pods. The first thing is we have liveness probe. You know what this liveness probe will do? It will check if your container is running or not. Checks container is running or not. If it is not running, it will restart it. We don't restart it. It will restart automatically. So all you have to tell is how how to check if the container is running or not. That is one thing. And when to check. I mean, any time period is there. No, within this time period, I should get a response from the application. Then it is healthy. So these kind of configuration we have to take. So Linus Probe will check the container whether it is running or not. If not running, restarts it. Got it? So that's about liveness probe. How it will check that we'll see, don't worry about it, but what it will do for now. So liveness will restart. It will keep on checking the container whether it is running or not. If it is not running, it will restart the container. Next we have something called readiness probe. You know what this will do? It will check the container if it is ready to handle the traffic or not. It will check the container if it is ready to handle the traffic or not. So it checks the container if it is ready to handle the traffic. So what does it mean is when we deploy something, if have you observed it will be in a pending state first. It will go to container creating and then it will be running. So when you use readiness probe, immediately after deploying your application, what happens is this will check the container is ready or not. I mean, any errors, container is okay. So until this check is finished, until this readiness probe check is finished, the container will be in a pending state. Once, let's say, readiness probe decides, okay, everything is fine with the pods, I mean, containers inside it, then it will make it as a running state. Now, after running state only, we can access the application. So that's about a readiness probe. Now, in this scenario, what happens is when we deploy something, let's say we are using two probes, Linux and readiness, we are using both. Generally, we use both, I mean, not just one. You know what happens? When you first deploy, readiness probe will come. It will check whether it is ready or not. Once it is ready, it will make it to running state. So first readiness probe will come. Next liveness probe will come after. So after once it started running, one by one running or two by two running, you can see the pod count, right? So after it start running, then in between if something goes wrong and container is not responding, then liveness probe will restart it. So first will be readiness probe. It will make it to the running state if it is container is ready. Otherwise it will keep on pending state only. Let's say readiness probe checking the container, but it is not okay. It will be in a pending state only. It will show us like, hey, readiness probe failed. Check once. You have to check it. So like this. So first readiness probe will come. It will check it, and then liveness probe will restart if the container is not responding after some time. So all we have to do is configure these things. Where to configure and how to configure, and most importantly, we are discussing what it will do, but how it will check the pods. I mean, how it will check the container is running or not, how it will check whether the container is ready or not. So there are multiple types how it will check. One is HTTP GET request. So we'll give a path or application path anything and the port number. What is the port number? I mean, the container is using for the application. So based on that, it will try to talk to the application. And of course, if we give the correct port, correct path, it will give the response back. Obviously, if it is not, it won't. And there is TCP request. TCP request also similar thing. Port and path it will expect. It will send a TCP request and it will expect the response back. And next is command. Command are like you can give any command. If it is executed successfully, then the container is running obviously. If this command is not running, I mean failed for some reason, then it's not running. So this liveness probe will do its duty. What is the first thing I told you? Readiness probe, right? So we can use any of this, not just all three types. So let's say I want to do HTTP GET method. So you can use it in a configuration file. And what happens is, let's say you're using readiness probe with HTTP GET method type, it will send a request. And if it got the response back, then only readiness probe thinks like a container is ready to handle that. Then it will make it running. Otherwise, it will be pending. Same with liveness also. Liveness also uses HTTP GET method. We can use the same thing. I mean, both use the same way of doing the health checks. The only difference is except when it comes, when it will do the health check. That's the only difference. So readiness will do at the beginning when we right after deploy the application. Liveness will come after once the application is not working or not working as expected after some time. So when this health check will do, that's the only difference. Remaining how it will do, both are same. We can do the same thing. We have to add these things in our manifest file. Let's see, let's try. Okay, we logged in catch HTTP, sorry, maybe HTTPD also fine. Let's copy this deployment I'm using. I mean, usually we write these things in a pod specification. Let's write it. ML validator, blah blah blah. This is the one for us, yeah, this is the one. Now go to here in the container spec. All we have to do is liveness probe. So we are defining the liveness probe. Of course, it is wrong because capital letter. Now here we have to define what is the method, what is the type of the method we want to do the health check of for pod. Maybe I'll use HTTP method. Anything, you can use anything. HTTP GET method is simpler and it will be easy. I mean, all are easy. I mean, there is nothing here, but HTTP GET method is clearer for us, right? I mean, for you also, since you deploy application, HTTP application, you know which port it is running and what is the URL. URL will be slash by default. So it will try to access it. If you give the wrong URL, of course it will fail. That also we'll see, don't worry. So HTTP GET. Path. What is the path? Slash. By default slash path. Next, what is the port? 84. So what happens is this liveness probes. It will try to talk to this using this approach. Okay, path is slash. Okay, and port is 80. Of course, correct. It'll obviously it'll get the response back. So it's healthy. If it is not, let's say we change the port number to 8080, and of course container port is wrong, it won't get the response back. It'll try to restart it. But that's okay. For now, let's like. Now we want to use readiness probe also, right? Simply copy paste it. Just come here. That's it. Same approach. I told you, right? Everything is same. You can use the same thing. Of course, we'll add few more things here. One thing is, what is it? Yes, yeah. So we have to add a time period. We told that okay, do the health check right, using liveness and readiness. But how many times it should do it? And what is the time period between this? I mean, I want to do continuously. Of course, okay, it will do continuously. But we are saying that if it is getting the response back, then it is healthy. But within what time we should get the response back? We need to define that threshold value. Otherwise, it's keep on checking. Maybe the response came after half an hour. That's not ideal case, right? So we should get the response immediately. That's what we are expect from the application. If we didn't give any timeout, even though the response will come after an hour, it will say it's healthy. So we have to define the conditions within this time period only I should get, and for every half an hour test it, or for every 1 second test it. So yeah, I was talking about we have to add time periods, seconds here, so that we can able to restrict within this time only we should get the response. Within this time only we should do the health check. So like this. So we have a couple of things like initial delay seconds. Sorry. So it's like maybe how much time we have to wait to do the health check. So initial delay 5 seconds means once we created it, after 5 seconds, it will start the health check. I mean, not this one. This will do after no, once it is not working. Same thing. Now period second. Maybe every 10 seconds means every 10 seconds it will do the health check. So when you create a pod for the first time, I mean anytime, sorry. So it will wait for 5 seconds, then it will do the health check. For every 10 seconds it will do it. Same thing, simply copy paste it. See, that's it. Oh wait, sorry. Syntax. Yes, syntax. Yeah, like this. So now what happens is just apply this. Let's try whether it will work or not. Let's just wait. Come on, man. Copy this. Update our HTTP file. Paste it. So readiness probe liveness is there. Let's try kubectl apply happen. Yeah, HTTP is created. Just describing the deployment. Hyphen N prod. Resource and limit. See, liveness and readiness. This is what we configure, right? If it is success, I mean, one time it got success, it will think it is okay, it's running. If it is failure three times means continuously, it will fail, obviously. And if you see timeout default is 1 second, it means within 1 second it should get the response. We can add this condition in our configuration, well, maybe for 5 seconds like that. It will it will wait for 5 seconds to get the response back. Pods are running, so it means all are good. Now let's do one thing. Let's purposefully add the wrong port. Let's try that. Maybe 8080 because 80 there's nothing in 8080 obviously it will fail. Let's fail it. Let's see. Oh, sorry. Some port number anything because we're trying not to make it work. Apply get ports. If you observe currently 0 are running. See? But by the time 7 seconds it will have been running. See? First describe the deployment. There's nothing as of now because it's waiting. It will test for 3 times. Continuous failures, it will fail. And what is the time period? 10 seconds, right? So it means 3 times 30 seconds we have to wait. Let's wait. 10 seconds over restarted. See, it's how it restarted. The liveness probe. We told liveness probe, hey, restart it. When to restart? Every 10 seconds it will try to restart. Let's see, maybe. See, it will restart. Because the parts are not ready. Readiness probe both are failing. See like that. It'll never come up. It will be 0 by 1 only always. Because the health checks, whatever we configured here, liveness and readiness probe, they are failed. They are failed. So obviously the pod won't come up. See. Now get back, update it to the correct port. Let's see if this works or not. Save it. We have to apply it, right? Apply configured. It's creating immediately. It will come, don't worry. We have to wait for 10 seconds, remember? See? See? That's how simple it is. You have to define the health check. You got it? What I'm saying? Is it clear? I mean, probes, liveness probe, readiness probe. There is one more probe also that I'll tell now. But these two clear, liveness and readiness. This will be very useful. Everyone uses this. I mean, for the health check of the parts, it will restart automatically. Liveness one and readiness will make sure it is running only if the body container is giving the response. Got it? Is it clear? Now let's. There is one more probe called startup probe. You know what this will do? This is all the same thing. Check do the health check, similar like your readiness and liveness. But what is the difference is, let's say scenario that application, some applications usually will be there. It will take too much time to start. General, I mean, this we cannot change anything on the application level. It's normal. And what happens? Let's say application is taking 5 minutes to start, as an example. That's the common general timing. Now, what happens in our case? We gave liveness probe and readiness probe as 5 seconds only delay time. After 5 seconds, it will start testing, and obviously it will fail. You know why? Because the application will start after 5 minutes. Correct? That's what generally is happening. I mean, in our case, let's say. But now, since the application starts after 5 minutes, generally, because the loading will take too much time. So many modules are there to load in the application. So due to that, it will take some time. Uh, but now, as per our requirement here, as of now, whatever we did the configuration, after 5 seconds, initial delay seconds we gave as five only just. After 5 seconds, it will start the health checks. Readiness probe first will start, and after that, liveness will start. But here it will fail because by the time 5 seconds it will start the health check, the application not started yet because why? It will take 5 minutes. So the health checks keep on failing. The liveness probe and readiness probe will keep on failing. But there is nothing wrong with the application. It just takes some time. What to do now? What to do? So of course, one way is you can increase the time to, let's say, 5 minutes, right? I told how many seconds? 300 seconds. You can keep like 300 seconds. Let's say here also 300 seconds. But this is not a good approach to use like this. Of course, you can use this, but it's not a good approach. I mean, after 5 minutes, it will start the health check, and until then, it will be blank. Not a good approach to use. That's why they have, let's say, what is it? Startup Pro. You know what the Startup Pro will do? Nothing. It will just do the same configuration. It will do the health check only. But you know what is the difference? Startup probe will run first. If I add a startup probe configuration here, that startup probe will run first. After application started, then only startup will get success and it will go to liveness and readiness probes. So if I add a startup probe now in the configuration, this will start first. Startup probe will start first, and once it is successfully, okay, I mean everything is okay, then it will start the ready. I mean then readiness and liveness will start. So liveness and readiness will wait for the startup probe. And now since our application takes 5 minutes, in the startup probe I'll give that hey 5 minutes. My application take 5 minutes. Please wait for 5 minutes. And you know what this startup probe will do? It will wait for 5 minutes. It will do the health check. Once the 5 minutes is done, once the application is ready, then startup probe will say, hey, application is ready. Now you can do your part. Then liveness and readiness will start. So startup probe has the priority now if I add it. Same thing, just copy paste the whole thing. Just here, start of startup probe. HTTP get, okay, same thing. Port, okay, ours is same. Initial delay seconds. You can give anything, period for period, 10 seconds, anything. So now after this first, now startup probe will start. Will do the health check, and it will wait for few seconds. So now once, let's say, once the startup probe is success, then it means application is started running. Then these things will do the health check. Let's say startup probe failed, it will fail. Pod will fail obviously. So it won't start. Now all we have to do is so simply. Awesome. Let's go copy, enter. Let me just copy this again. Startup probe. Yeah, I have it here. First, it will do the health check. Once application started running, then remaining probes will start health checks. kubectl pply has an air first to kd. It's created. Startup probe is happening. That's why 0 by 1. So now it will start. See, now readiness probe is done. So first startup probe will start. How do I know? Of course, we'll see the same output as readiness, but if you add it generally, it will wait for that much time. Where is it? Yeah, sorry. So here. So startup probe will be useful if we have an application, which takes a lot of time to run start. Obviously, we'll do have some things like that, but that's okay. So at the time it will be useful because then if you don't use the startup probes, if we have application is taking longer time, what happens, the readiness probe and liveness probe will think that application is not healthy, but it's not the case, right? It is healthy, but it is taking some time to load. So at the time startup probe will help you. So because startup probe, it will wait until you start the application, obviously. Of course, we can change, increase the timeouts, but it will wait until once it is gets success, then only it will move on to the readiness and liveness. So here, I mean, why the startup probe? Can we increase the timeout in the readiness and liveness probes? Yes, you can increase it, but startup probe, the thing here is, it won't decide the application is failed. It'll do keep on checking the pod until the application is ready. That's the only thing. Remaining things, if we let's say readiness probe or liveness probe, I change it to 300 seconds, 5 minutes in our case. 5 minutes it will wait to do the health check, and every 5 minutes. Like, what if in between, application is down? It won't, do anything. It won't. Liveness probe won't restart it. What if, application is down at the third minute? It won't do anything. It will wait until 5 minutes. So this has to do this work, their work, immediate actions. For startup probe should wait for application to start it. That's the only purpose of that. And once application is started, there is no use of startup probe. Only this. Because once it is running after some time, it got suffer some reason not running. It will sorry restart it. That's all. So is it clear? Probes topic. That's about the probes. It's commonly used, very simple. I mean, so if it is clear, let's move to the next topic called init containers. These are small topics. I mean, that's why I'm just telling multiple things. Init containers. What are init containers? If we go to our pod, where is this? Of course, the port number. Sorry, yeah, this is the container. Our container, HTTP container. Okay, we are creating a deployment. Inside that, we defined a pod specific pod template, pod specification, and we are creating a container. The name is test, and image is HTTP. Okay, what is init container means? Init container also, one of the kind actually. Like, these containers, just like another container, but it will run before your main container. This is our main container, obviously, within the pod. If we have two containers, two main containers. But init container is like, it will run before this main container. Why? Why it will run? Let's say I have a scenario. Mm, you're about to run the application in the main container. But before running the application, you want to prepare an environment, or you want to install some package, or you want to download something, or you want to create something. As an example, anything it can be, or you want to install a dependency, or DB has to be initialized. So these kind of things you have to do. So how you can do this? I mean, before creating a container, before creating the main container, you have to do all these things. How to do all those things? Those can be done by init containers. Where is it? Same thing. Init containers. Is my voice is not coming? Is my voice okay now? Can someone say it? Hello. Am I audible? Sorry. Sorry, am I audible now?
Yes, no.
I don't know why today it's getting muted and getting cancelled. I'm not sure. But yeah, let's continue. I'll try to see. So this this container will run init containers, nothing but just we're creating another container. That's it. I mean, not really any extra thing, not any extra abilities are not there. This container, init containers are nothing but another container which we are creating before running our main container. So why we need to run before the main container is, let's say scenarios, there are multiple scenarios that uh, before running our main container, I want to prepare environment for this. I want to download something or I want to initialize the database so that application can connect, or I want to download the dependencies or install the dependencies. So these kind of things actually has to be done before the main container. So at the time what happens is you can use this init containers. Let's say in my case, I want to print something before the main application starts. So first when you deploy this, what happens is init container will start. It will create the container based on whatever the image you give, and it will execute whatever the commands you give. Once those are successfully executed, then the main container will start. So these are for use case where you want to run something before your main application starts. So main application is this, obviously container is the main application. Before starting this, you want to do something, let's say. So at the time you can go for 8 containers. These are temporary. Once the task is done with the init container, that will delete automatically. So we don't need to do anything. So let's name test init container something. What is the image you want to use for init container? For I don't have any use case specifically, so I just want to print something. I'll use this something called busybox image. Now command. So we can give any command. So this will run and show for us something. Echo preparing env for main container. Something. I'm just printing some variable and just sleep for 10 seconds. So hopefully this should work. Now what happens, when I deploy this, first this container will start because this obviously will start before our main container. It will do its task, whatever the command we give. Once the command is successfully done, I mean it will print something and obviously it will sleep for 10 seconds. When this is done, our main container will start. Got it? So you can write anything, any scenario here. Let's say you have something to install, something to create. You can do anything. Obviously, I forgot to. Okay, let's. Mm-hmm. Let's delete our application. Yes, now let's paste this. Sorry. Now we have two containers. I mean, Container is one. This is the main container, and this is init container. So init container obviously will start before the main container, execute its task, and it will delete once it is done. Let's see. Wait. Somewhere line 21. Obviously at the command line. So where is there this command wrong? Let me see. Comma instead of comma I gave. My bad. Let's try created. Now kubectl. See init container first it will do. See the status here init. Because in init container we have mentioned right, it will do the task. See now init container task is done. Whatever it's printed, it's done. Now the main container started. See, first is init, then the main container started, and it's deleted. We don't see anything. It's gone. It automatically deletes it. That's how we use the init container. So mostly it will be useful for when you want to do something, any kind of task before your main application container starts. Main container starts. So at the time you'll be using this. Sorry. So is it clear? So is it clear about init containers? Starts before main container to do anything. Any task, whatever you say it will do it. I mean, based on your requirement, obviously. You have to, of course, I use the image, right? It's not just the default image. You have to use your own image to do that your own task. Just for testing, I using this image, but we have, let's say, scenario you want to create the directory. So you have to make sure the image is, you have to build your own image to create a directory. Or you have to do some, download something. You have to write Docker file to download something, build your own image and give the image there. It has to download. So like that. Based on your use case, you have to give. So hope it's clear. I mean, you need containers. So it will run before your main containers. Do any task and whatever the task you mentioned. So there is similar thing. There is one more thing called what is it? Sidecar containers. Side sidecar containers. Yeah. So init container runs before your main container, right? Well, that's what I told. Sidecar runs along with your main container. It will run along with your main container. The main container will be running, and then uh, your container also will be running. I mean your main container. Why it will run like that? Why it will run like that? Why it will run is, I mean, why we need to run the sidecar container? Let's say you have a scenario. This sidecar container mostly useful for let's say you want to install some monitoring agent for your application. At the time you use sidecar container. So the monitoring agent has a sidecar container. The agent will run and monitor your application. So like that. So like what is the advantage of running this? This sidecar container runs along with your main container. It means if you remember, we have two containers earlier. One is HTTPD and one is Tomcat. We have the both are running, right? They're both are running. Similarly here also. I mean there is no sidecar containers over there. Both are main containers because we are treating them as a main containers. But here we are treating one as a sidecar container. This sidecar container we are deploying something anything let's say based on your requirement. So what happens here is when you run two containers in the same pod, they both will share the same IP address. They both will share the same storage. I mean, whatever the disk and everything. They both share the memory and everything. So they are tightly linked together. So one can access another easily. I mean, because they are the same thing. If you're in the same house, obviously you will communicate together. Correct. So like that here also, the containers are in the same pod, same house. They can able to talk to each other without any issues. Got it? So how do I use this sidecar container? Nothing, no extra things, nothing. Of course, keep the init. That's fine. Keep it. There's nothing wrong. Now simply copy paste this for a sidecar container. I'll just test sidecar as an example. Let's see. You can run anything based on your use case. But what is the general use case to run a sidecar? Mostly we are also using for a monitoring agents. There are monitoring agents, there are log agents, which will fetch the logs from application, which will fetch the metrics from application. So for that use cases, we are using the sidecar container. The sidecar container won't delete after some time. It will run along with your main application until you delete it. Let's say I want to run something Tomcat. Sorry, let's write Nginx Tomcat. It will take too much time to download. So now this Nginx is a sidecar container. Obviously, port I have to give, or you can ignore it if you don't want access. All are fine. Nothing. Everything is fine. So now this Nginx will run as a sidecar container along with your HTTP container. It's like no extra permissions, nothing. We're just creating another container along with your main container so that they can able to talk to each other. Why I need to create? If we have two applications, we can create. If you have a scenario like where any kind of agents that he wants to install, so you can create like at the time also. Simply let's delete, paste it. Let's see if it is work or if the syntax is wrong or not. She says there's some wrong. Oh, wait. I know what is wrong. I forgot to change the comma. It's created. It will get for Python prod. Obviously, let it go. 10 seconds. We gave the 10 seconds sleep time. So obviously now it will listen. Pod initializing, running. Some error is there. See, let's check the log. Describe first. Describe pod slash space hyphen m namespace. Obviously, there is nothing wrong as of now. You know why this is happening? HTTP application container. Let's check sidecar. It's failing for some reason. Let's try again. Now check the log. Kubectl log 7 pod slash pod not found. Oh, sorry. It's fine. Okay, icons. Could not bind. You know why is the error? You know why? We gave the sidecar container, right? And we are using Nginx image. What is the default port of Nginx? 80. And Apache also the port is 80 only. Both both are using same port, which will eventually fail. So if I change the port number, Nginx will fail. Let's try. Let's change the port number. Let's try. Apply. Yes. Get ports. Its init container is running. 10 seconds. Watch. 10, 11, 13. See, it's running. Let's wait. One by one running. Wait. Again error. Crash to back. Cool. Check the logs. Something. All you have to do is change the container ID. Still could not bind. It's same. We can't use Nginx image obviously. That's my mistake. Let's use maybe Tomcat. I think Tomcat should be present. Let's try this. kubectl delete -f st3d kubectl apply -f st3d. Let's see. Of course, the old is terminating. It'll take some time. Initializing. Let's see. Running. Let's wait. Why it is still terminating? It's got stuck, but it'll take time. Don't worry. See now it's running. Nginx and Apache both are using same port, so we can't use that. So obviously that's not Kubernetes error. That's mistake from our side. We shouldn't have used services with same port. Now Tomcat port is 8080, right? So no errors. HTTP Apache will run in 80 and Tomcat will run 8080. So no conflict. See, just Sidecar is nothing like running another container along with your you know main container. There is no extra features, nothing. You remember we were running Nginx and Tomcat both two containers. Here also same. But Sidecar, why we call it Sidecar? Why? Because instead of running our application, Sidecar we'll use mostly for a support kind of thing for a main container or an extra thing for a main container for monitoring or for logging for these kind of things. So at that time we call it Sidecar container. That's it. If you're running two containers, two applications, they're just normal containers. If running one application and another container for the same application, but another extra feature for the same application, at the time it became Sidecar. Just another term, that's it. But the container creation is same. So is it clear? Mm-hmm. Any doubts? Any doubts in today's class? Like we discussed, first thing is this one: probes, liveness probe, readiness probe, and startup probe. Startup will come first, and once the startup is okay only, then uh, liveness and readiness will start. Because startup will be useful for when we have applications which takes too much time to load, and liveness knows when to restart the pod container if it is not running, and readiness, it will make sure the application is ready, then only it will make it to the running state, the pod. Otherwise, it won't. It won't make it to the running state. It will be in pending state. These are about the probes. So we have init containers where it will run along with the main container. I mean, before the main container, sorry, to do any task for our application. We can write anything, any task over there. It will do the task. Once the task is done, it will delete automatically and the main container will start. Let's say in container task is failed for some reason, it will throw error. So I have to figure it out. So init container runs before the main container to do anything, any task. Now we have one more thing called sidecar container, uh, which will run along with the main container. So it's just like another container where it will be running along with the main container. But like we scenarios like we'll be using this kind of sidecar container. When we say the container as a sidecar container is when it's not another application, it's just a part of this main container. I mean, like a task. or a thing related to this main container. So that time we'll say it's a sidecar container. So hope it's clear. Any doubts so far? And I forgot tomorrow we'll have class at evening time. I'll let you know something in group also. Okay.
Okay. Okay.
So any doubts so far? I take it as no then. So do practice and we'll meet tomorrow evening. Got it? Bye all. Bye.